personalized learning using PMDPs, and let's get started. So we are all familiar with a usual pacing of a university course. You start in week 1 and usually proceed to week 2, week 3, etc. Where each week's material usually builds on concepts from earlier weeks. This pacing proceeds in linear fashion for all the students involved. But such a one-size-fits-all approach to course pacing may lead to inefficiencies. So students may have different starting knowledge. Some students learn quickly and are ready to move to the next level, while still spend time on material they have already mastered. And some students learn slowly and need more time examples to digest material. We can actually adjust pacing of the course using AI. That is, we can reduce wasted time for students with better starting knowledge or for those students who learn faster. And we also can improve material adoption for those students who have weaker starting knowledge and or who learn more slowly. And the idea is to use POMDPs, which is a partial observed Markov decision process, to adjust pacing. That is action A, based on estimating current student knowledge level. We denote this student level to be S, but it is unobserved. We infer this student level from the observed assessment of student knowledge, denoted as big O. So there are 10 actions. This is the material of what week to provide to a student and to test on that material. There is a reward of -1 for each time step. There are 10 knowledge states overall that indicate the student knowledge level, and we assume that there is a uniform distribution of 1 to 5 at the start of the course. We also make some assumption with regards to the observation and transition function. And observation can be of two types. It's either correct or incorrect. Whenever you provide, for example, material at level 5, there is action 5, and you can observe whether the student solves this test correct or doesn't solve this test is incorrect. And of course, for this we use QMDP algorithm, which is a variant of a value iteration algorithm, and you can read about it elsewhere. We select a baseline to be the usual way a course is taught at a university. That is, teach 1 week a certain topic, then move to the next week's topic, and for modeling purposes we assume that each week requires 4 steps. You can think about each step as an element of a course, such as lecture or section. And on the right, we can compare it to our agent, where we select an action on what level to teach the course, then teach and test at that level, look at the observed result of the test, and infer from it the current student knowledge level. And then the cycle repeats as we need to select a new action based on our estimation of the student level S. In both cases, if a student passes a test at the highest level, A, which is equal to 10, then he passes the course. And the goal for our intelligent tutoring system is to select such a policy that a student passes level 10 test taking as little steps as possible. And our results show that with our tutor, a larger share of students finish earlier. So the distribution of rewards is better. And we can also visualize how the tutor adjusts policy according to observations of the test results. So you can see that for the agent starts around the top of the expected distribution of initial knowledge, which is 5, and then adjusts according to observations. If a student starts high, is learning fast and is lucky in terms of getting the tasks correctly, which is going to be 2 in orange, then she might master the course quite quickly. Alternatively, the policy adjusts if there is an indication based on observations that the student starts with low knowledge and is slow learner lagging behind. You can see that like KMDP4 Crimson is an example of this. Also, a smaller share of students fail the course, that is, don't pass the test at the level of 10. And you can see that from the picture as the red area for the agent is smaller than the gray area for the baseline. And even for those students who do not pass the course, distribution of the knowledge level is higher for our approach. You can see that the red distribution is skewed to the right, that is to higher pass test level than the gray distribution. So overall, our results show that personalized learning can lead to higher course completion rates, to larger time saved for students, and to higher knowledge level even for those who fail. And the future work may be concerned with estimating model and individual student parameters using real data. And thank you so much.